Hi, it's Mr. Smith, and in this video we'll be going through section 2.2. So here we're organizing quantitative data. In the last section, 2.1, we were organizing qualitative data. So let's go ahead and get started. So first of all, it depends on if we have discrete or continuous data. The first step in summarizing quantitative data is to determine whether the data are discrete or continuous. Now remember, discrete data is countable. That would make continuous data not countable. So generally that means that you can count the number of pieces of data or possible pieces of data. You know, it's a number like 5 or 15 or even a bigger number like 55 or more. If the data are discrete and there's relatively few different values of the variable, then the categories of the classes will be the observations. So we'll see that in the next slide. Just like it's very similar to qualitative data for that case, the discrete case. And then if the data are discrete but there's many different values of the variables, or if the data is continuous, the categories of data, so here are categories of data, must be created using intervals of numbers. So we're going to have categories of data with intervals of numbers, like for example 10 through 20, instead of just the number 1. All right, let's go ahead and move on to the next slide. And we'll look at an example of constructing a frequency and relative frequency distribution from discrete data. All right, so you can see here that we have relatively few different values of the variable. You can see that in our chart here. And let's go ahead and just look at this. It says the manager of a Wendy's fast food restaurant wants to know the typical number of customers who arrive during the lunch hour. The data in Table 8 represents the number of customers who arrive at Wendy's for 40 randomly selected 15-minute intervals of time during lunch. So we're going to say that's like 12 o'clock to 1 o'clock throughout the week. And so they're randomly choosing 40 50-minute intervals. For example, during one 15-minute interval, 7 customers arrived. Construct a frequency and relative frequency distribution of the data. All right, so let's go ahead and see what that would look like. Of course, this is our raw data, and the first thing we do is create a frequency distribution for that. And so you could work off the raw data we were just looking at. Let me go ahead and move this down just a little bit. And you can see, you could tally all that up. This is all done by hand. So you can see there was one customer in one of the 15-minute intervals. There were 6 in another. In fact, the greatest amount was there were 6 customers in 11 of these 40 intervals. So remember, you can get the relative frequencies by dividing each frequency by the total number of frequencies, and we said there were 40 of those. So notice 1 divided by 40 is giving you 0.025 as an answer, or 25 thousandths. Of course, that would be 2.5%. So basically, there was one customer in a 15-minute period during lunch hour. It was one time in those 40-minute intervals where you just had one customer. You could see the most common was when you had 11. In fact, that was 275 thousandths of the time, or 27.5%. So 27.5% of the 15-minute intervals had 6 customers. That was our data there, or the number of customers. All right, so let's go ahead and move on to the next slide. I do want to say that this is certainly something you can do pretty easily in StatCrunch, and I would encourage you to look at the author's video in my math lab for doing that. It's pretty simple. I think the video is 5 minutes or less long. Let's go ahead and look at the next slide. So we want to talk about what a histogram is. It's very similar to a bar graph, at least the way it appears. So it says a histogram is constructed by drawing rectangles for each class of data, kind of like we did with qualitative data. The height of each rectangle is the frequency or relative frequency of the class, which was similar to what we did with bar graphs. The width of each rectangle is the same, and the rectangles touch each other. So that's where things are different when it comes to a histogram versus a bar graph. All right, so let's go ahead and continue and look at a histogram for, let's see, for this discrete data that we were just looking at. So construct a frequency histogram and a relative frequency histogram of the number of customers arriving at Wendy's using the data previously used from Table 9. And so this is what the histogram would look like. So you can see, in this case, our categories are just the actual observations. There was 1 customer here, 2 customers here. I should say, this is the bar that measures how many times there were 2 customers in a 15-minute period. Remember, we said 6 customers was most common in a 15-minute period, and that happened 27.5% of the time. So you can read the graph here, or the histogram, very similar to what we were just looking at our table, frequency table, and relative frequency table. And again, I would point you to the video in my math lab that's by the author, and he'll show you step by step how to do that. I also may be making some videos for some of the homework problems if you run into any problems. Let's go ahead and move on to the next slide. So again, I do want to mention or stress that in a histogram, the rectangles will touch, but in bar graphs, that's not the case. Let's look at continuous data in tables. So classes are categories into which data are grouped. Let's see. You know what? I think I want to mention just a couple of things I forgot to say on that last slide. So one of the things you'll have to do in the homework is you'll have to be able to read a histogram and answer some questions. Like, for example, we know there were 40 random 15-minute intervals that they looked at, but if they hadn't have told you that, you can see that you have there was one time where there was 1 person that came in a 15-minute interval. Remember, these are our frequencies. Here you have 6. 6 times you had 2 people. 1 time you had 3, and so on. And if you add up all those frequencies, remember the one that occurred the most was we would get 6 people, and that happened, you can see, 11 times. But again, you should be able to add all those up, and you could get your total of 40. And actually, I think that's about all I wanted to say. The only other thing I would mention here is, um, actually, that's all I'm going to say for that for now. Let's go ahead and move on to the next slide. So classes are categories into which data are grouped. When a data set consists of a large number of different discrete data values, or when a data set consists of continuous data, we must create classes by using intervals of numbers. So for example, in your homework, you're going to do this one problem where you look at IQs of 7th graders. And I think there was 200 people that were in this survey. And at the highest level, you had 150 to 159, and then right below that, 140 to 149, 130 to 139. And I won't write them all out. We don't normally do this, but I'm just trying to save some time. And the last ones were 70 to 79 and 60 to 69. And so these are our classes. And notice the range of numbers. We go from 150 to 159, 140 to 149. Now, with IQs, they are rounded to the nearest whole number. And so in this case here, the next number would be 150. The main thing is, there's a few things we'll talk about, but one of the things that's important with these classes is they should all be the same size, and there should never be any confusion about where a piece of data goes. Which class does it go into? They should all be the same size, and there should be no overlap. All right, so let's look at some of the rules of classes. So here's another example. You can see we have age ranges here. Let's see, it says table 10 is a typical frequency distribution created from continuous data. The data represent the number of mothers in the United States aged 15 to 54 who had their 4th child in 2016. So this is a little amazing. 15 to 19, you had 443 moms that had their 4th child at that age. That's pretty amazing. But anyway, all to say, keep this in mind. So for example, in this one, it's ages 20 to 24. And what you can see here is like you could be 19 but almost be 20, and you still fit into this category here. You don't switch to 20 until you're exactly 20. So anything over 19, all the way up until the time you're 20, you'd be grouped here, or you'd be placed here. And so that's something you have to think about when you create these ranges. So it actually goes above 19, but less than 20 here. All right, so it says the lower class limit of a class is the smallest value within the class, while the let's go ahead and just point this out. So 15 would be the lower class limit for the first class here. And let's go ahead and point to the last class, and the 54 would be the upper class limit for the last class, and the upper class limit for the first class would be 19. So each class has a lower and upper class limit. We said upper class limit is the largest value within the class. The lower class limit for the first class in table 10 is 15. Oh, actually, we talked about that. The class width is the difference between consecutive lower class limits. So basically, go ahead and look at the 15 and the 19 here. 20 minus, I'm sorry, the 15 and the 20. 20 minus 15 equals 5. And so that is the class width. Whoops. That would be your class width. And again, this, well, I mentioned this on the previous slide, the class widths have to be the same for all the classes, with one exception, and we'll talk about that in just a second. Let's see if there's anything else here I wanted to mention. Nope, that'll be it. Let's go ahead and move on to the next one. It says, one exception to the requirement of equal class widths occurs in open-ended tables. So on occasion we may see this. A table is open-ended if the first class has no lower limit or the last class has no upper limit. And so you can see with our age groups here, we have 25 to 44, 45 to 64, and 65 and older. If you look here and you subtract 45 minus 25, you can see that the class width is 20. But that's not true here. But it's true for the others. So basically the lower limit here is 65, but it's open as far as upper limit is concerned. All right, let's go ahead and move on to the next slide. So we're going to look at organizing continuous data into frequency and relative frequency distribution, into a relative frequency distribution. Let's see, the data in Table 12 represent the total fine, including late penalties, in dollars for a simple random sample of 50 parking and camera violations in the city of New York. So I'm guessing with its camera violations, maybe that's going through stop signs or probably stoplights even more. So that's our data. This is in New York. Construct a frequency and relative frequency distribution of the data. And so these are the fines. Notice they're in dollars and cents. So this is money we're talking about here. And let's go ahead and move on to the next slide. To construct a frequency distribution, first create classes of equal width. Table 12 has 50 observations that range from basically $65 to $322.61. So we decide to create the classes such that the lower limit of the first class is 50 and the class width is 25. So that's arbitrary. There's no fixed value. This is something with experience, and it's a little bit of an art trying to figure out exactly how to go about doing that. But basically, if it was, the lowest amount was 65, 50 is a nice number that we could start at. I think 60 would also be a reasonable number. Let's continue looking at what they said here. So it says tally the data as shown in the second column of table 13. And actually, we're just going to go ahead and move on to the next page. Let's see. I do want to mention, one of the big things here is you're noticing your range of data does go from $65 to $322.61. You want to make sure your classes cover that range of data. All right, so let's move on to the next slide. And so now, just like we did with discrete data, we can do similar for continuous data. But notice this time we have our classes. So you can see we go from 50 to $74.99 because 1 more cent, because this is all money we're talking about, puts us at $75. So notice you can see that the width of the class is 75 minus 50, or 25. So we had talked about that. And let's see, so here's our frequencies. And again, our relative frequencies. Remember, there were 40 observations, or no, there were 50. And again, you can see relative frequencies are found by dividing the frequency here by the total number of frequencies. And of course, all of these we know add up to 1 or 100%. And you could read each of these as a percent. So for example, 26% of the data, that's right here, for $200 to $224.99. So that's our most common frequency, or class that has the greatest frequency. All right, let's go ahead and move on to the next slide. Again, this is something that you can, the author does have a video if you want to do a frequency table for continuous data and also relative frequency chart. You can watch the video in my math lab that's by the author. Let's go ahead and continue. So the choices of the lower class limit of the first class and the class width were rather arbitrary. So we discussed that. There's not, and I want to emphasize this, there is not one correct frequency distribution for a particular set of data. However, some frequency distributions can better illustrate patterns within the data than others. So constructing frequency distribution is somewhat of an art form. So some frequency distributions can better illustrate patterns within the data than others. So literally you can, when you're in StatCrunch or some program like that, you can adjust your classes and look at the distribution of the data and try to figure out which chart or which histogram captures the shape of the data the best, or what's really going on. All right. So notice it says to use the distribution that seems to provide the best overall summary of the data. Really trying to get a good idea of what the data is telling us. And we're looking for the histogram that presents that the best. All right, let's move on to the next slide. Okay. So guidelines for determining the, sorry about that, the lower class limit of the first class and class width. So choosing the lower class limit of the first class. So choose the smallest observation in the data set, or a convenient number slightly lower than the smallest observation in the data set. Determining the class width. Decide on the number of classes. Generally, there should be between 5 and 20 classes. That's a guideline. The smaller the set of data, or the data set, the fewer classes you should have. So you'll notice we had 50, so I wouldn't say that's real small. So we're somewhere in the middle, right, between 5 and 20, a little bit closer to the 5, so it's not a real big set. Again, this is something you get better at with experience, but it's also something you can play around with quite easily with the technology that we have. You can try different widths. But we do have a guideline for determining the class width. So basically, if you subtract your largest data value minus your smallest data value, and you divide that by the number of classes that you want to have, and then round this up to a convenient number, that's how we can, this is one of the ways you can find, or I should say this is a guideline for finding the class width. So you can see here we subtracted the highest minus the lowest fine, and we divided by 11, which we had already chosen as far as the number of classes, and we got 23.4 basically. So they rounded up to 25 because that's a nice number to work with. And so that's where the 25 came from. We had said we're going to start at 50, and then our class width was going to be 25. So let's go ahead and continue here. So now you can see the histogram for our data, and notice how the classes are represented. So it's a little bit hard to see this, but here you're going from 50 to 75. There was one fine there in that amount. And then here from one, so notice there was no frequency, or we didn't have any fines between $75 and $100. And then from $100 to 25, that was our next class, which had a frequency of 7, and so on. And so very similar to what we did before, but notice it's not just a number like 5, 6, 7, that kind of thing. These are ranges of numbers. These are our classes. And again, they should all be the same size. There should be no overlap. Notice our bars touch. And I think that's about all I have to say about that. So again, I would just say in order to see how to do this in StatCrunch, I would encourage you to watch the video that's in my math lab. And I think that's all I have to say about that graph. So you can see it looks quite similar to what I was just looking at in the previous slide. Let's go ahead and move on to what are called dot plots. And I think I'm going to stop right here because we've been going about 26 minutes, and then I'll finish out the lesson with one more video. All right.